This video is going to go over a few examples on how to calculate the enthalpy change for phase changes using a heating and cooling curve. First example says how much heat in calories is needed to melt 150 grams of ice at 0 degrees Celsius. So the first thing I have my students do is actually sketch out a heating and cooling curve. And I want us to understand the steps that are needed to take. So it says we need to melt ice at 0 degrees Celsius. Well, this is 0 degrees Celsius. This horizontal portion is 100 degrees Celsius. So we're starting here as a solid on the left side of the diagram, and we're actually going to head right here to this portion of the diagram. We're going to melt the ice at 0 degrees Celsius. We're not going to raise the temperature. We're just calculating how much heat it takes to melt the ice. So we're going to need the molar heat of fusion, 334 joules per gram. And we're actually going to use dimensional analysis here. We're going to take 150 grams of ice. I'm going to use my 334 joules per gram as a conversion factor. And then because that's joules, I also am going to use my old conversion of 1 calorie equals 4.18 joules of energy in order to get calories, because that's what the question asked for up here. When we calculate, we get an answer of 1.20 times 10 to the fourth calories. Another way of solving, Q equals M times delta H. Q equals the mass, 150 grams, times 334 joules per gram. I would get an answer, and then I would have to convert into calories. Second question, how much heat in calories is needed to heat the liquid water in the above problem to 20 degrees Celsius? So again, let's go ahead and look at this question. Looking for heat, I'm going to have it in calories again. To heat the liquid now, it's a liquid, to 20 degrees Celsius. So we're going from 0 degrees to 20 degrees. We're not going through a phase change, we're just going through a temperature change. So on my heating and cooling curve, I'm going to go ahead and draw that out. I'm starting here at liquid water at 0 degrees, and I'm going to heat it up. Remember, this is 100 degrees, so I'm going to heat it up to about 20 degrees, somewhere in here. So I'm going to use Q equals MC delta T on this chart. The specific heat for liquid water, I have two choices, 4.18 joules per gram Celsius or 1.00 calories per gram Celsius. And because I'm looking for calories, I'm going to use the latter. So Q equals the mass, which is still 150 grams. I have not changed it. Specific heat, 1.00 calories per gram Celsius. And then the change in temperature, remember, delta T, for the change in temperature, I do the final temperature minus the initial temperature. So 20 degrees minus 0 degrees, which is 20. And then I'm going to click forward to get my final answer of 3.0 times 10 to the third calories. 50-gram sample of ice is held at negative 10 degrees Celsius. So this is a brand new problem for us. Will 270 calories of heat be sufficient to raise the temperature of ice to 0 degrees? So it's a yes or no question. So let's keep that in mind. Will it or will it not? I'm going to sketch out my curve. I'm at negative 10. So that's 0 and that's 100. I'm at negative 10, and I'm curious to know if I can raise it up to ice at 0. So this is a one-step problem, and I'm going to use Q equals M delta H, Q equals MCAT, because I have a temperature change. The mass is 50 grams. The specific heat of ice, I have two options, 0.5 calories per gram Celsius or 2.1 joules per gram Celsius. I'm going to use calories here. 0.5 calories per gram Celsius. And then the change in temperature is going to be final minus initial. Final temperature is 0 degrees minus the initial, which was a negative 10. So that's a change of positive 10 degrees Celsius. And a little bit of mental math, but the answer is 250 calories. So the question said, will 270 calories be enough? So the answer is yes, by 20 calories. How many calories are released when 36 grams of steam at 100 degrees Celsius condensed to water at 100 degrees Celsius? Draw my curve, 0 and 100. I'm converting 36 grams of steam at 100 degrees to water at 100 degrees. So this is a one step. I'm on the horizontal portion, so I'm going to use M delta H. And this would be the delta H that I need for condensing. So my delta H values for that are either 2260 joules per gram or 40.7 kilojoules per mole. I'm given a gram mass, so I'm going to use the 2260. The mass is 36 grams. 2260 joules per gram is the number I'm using here. Now, the key is I am traveling backwards on the graph. So these numbers are negative. So I'm going to have to turn this to a negative 2260. I'm going to click forward to get my answer. And I get negative 1.9 times 10 to the fourth. And that was in calories. So what they had to do was use the conversion 4.18 joules as equivalent to 1 calorie in order to convert to get that final answer. And the last one we're going to do, how many calories are needed to convert 5 grams of ice at negative 15 to steam at 130? So 5 grams of ice at negative 15 to steam, which is above 100 degrees. So I have 1 step, 2 step, 3 step, 4 steps, 5 steps. Okay, so we're going through both phase changes and temperature changes here. So we're going to have to use Q equals M delta H twice and Q equals MCAT 3 times. So the first step is Q equals MCAT. Here's the mass. Here's the specific heat for ice. And then here's the delta T. We solve and get 38 calories. So this is for step 1. Next step, we're going to use Q equals M delta H, or you can use dimensional analysis. They're using the delta H for melting. And then they're converting joules into calories so that I can keep all my units the same. And so for the second step, they get 4 times 10 to the second. So that's step 2. And what we're going to do is combine 1 and 2. And then eventually we're going to combine 3, 4, and 5. So let's keep going. Step 3, we have a mass, specific heat of H2O, using calories, and then the delta T change in temperature, which is 100. So our third step is 500 calories. Fourth step is going from liquid water at 100 to steam. So I'm using my delta H for vaporization. And then I'm converting to calories, and I get 2.7 times 10 to the third. That is step 4. And my last step is a phase going through MCAT. M, C for steam is 1, and the delta T is 30 degrees Celsius. Final answer, 150. So I have 5 different answers. And to get the total, I'm going to add up step 1, step 2, 3, 4, and 5. And the final answer here is going to be 3,700 calories.